Okay, this is Nate Johnson and Tony Eisminger from Universal Synaptics. We're here to demonstrate the intermittent fault detector. This is the portable version. The IFD technology, intermittent fault detection technology, comes in the portable version or a depot level version, IFDS, intermittent fault detection and isolation system. IFDS focuses on the troubleshooting of chassis of LRUs and components. The portable can do smaller components, but it is mainly focused on harnesses and cables. So what we have already done up to this point is ran what is called auto map. We're going to talk through about connecting to the unit under test. First and foremost here, our unit under test is what we call our fault emulator, our intermittent fault emulator, or demo box. And as you can see Tony holding it up there, it is a 48 switch box that allows us to demonstrate open continuity issues and then also intermittent type issues. We show continuity opens by pressing and holding a switch. When it's released, it's closed. Or we can demonstrate a continuity issue by opening these banana clips on test point 15. This is also how we would demonstrate intermittence with the scratch test or with light tapping on the switches themselves across the demo box. So with environmental stimulus, intermittent issues do come out, and that's what Tony just demonstrated by the light tapping. So we'll showcase what the tester does from a continuity, shorts, and then our specialty, which is intermittent fault detection. So first and foremost though, to connect to the IFD, we have a requirement for an interface test adapter. This ITA that Tony has there is simply just a 50-pin D-sub connector on each side. So Tony's gonna plug it into J1 on top of the IFD itself. And then he's actually already had it connected to the other side, connected to the UUT with a similar 50-pin D-sub connector. Okay, so we're at the home screen now of the tester. This tester, the portable version, is all touch screen. But Tony has a mouse connected. It does have a USB port for a mouse or a printer or a thumb drive to pull off reports and analyze data. So first and foremost, Tony is going to go in, and like I mentioned before, we have already ran what's called AutoMap. AutoMap finds the true as-wired configuration of any UUT or any component or harness that you have connected. It'll find the true as-wired configuration of that component. And that is important. Oftentimes we find issues with schematics or technical orders, data that oftentimes is incomplete. It's been compiled. There's been field mods or jumpers or whatever have you that has caused the schematics or that as-wired configuration to change. So AutoMap is a great tool for configuration control, making sure that everything lines up and is good. So we've ran AutoMap for this demo box previously. We won't show that in this demonstration, but Tony's simply gonna go and select that saved map that is stored on the tester. So he's selecting the map group, which is demo, and he is now going to select the fault emulator map itself. It also has a spot for serial number, which allows for serialized tracking for repairing similar assets of the same kind. So we're now just gonna simply push start and it'll move to a continuity test. Green shows pass. Move to shorts, green shows pass, and now we hop into intermittence mode. It is important to recognize the passes in the continuity and the shorts tests. They are scanning tests. It scanned through each of those 48 points and it passed. The test starts and it stops. In intermittence mode, even as I'm talking during this demonstration, we are testing. Right now it's as if we have 48 latching oscilloscopes, monitoring every circuit, every connection of this unit under test. And so in intermittence mode, we are not scanning or sampling, we are monitoring every circuit simultaneously and continuously. So I'm going to zoom back out and allow Tony to kind of demonstrate by holding the demo box up a bit. And he's just going to lightly tap on a few of these test points. And you can see the screen is picking up intermittent events right here on test point 20, 19, 27, 10, and 47. So Tony, go ahead and lightly tap test point 44 and we'll see 44 light up on the board. All right, so it lit up here where Tony was tapping, and then test point 44 in the results side as well shows 6 events. So intermittent events are different than one open, right? Or one short. These events are those low-level micro breaks or momentary discontinuities that occur oftentimes in the nanosecond range. We abort a mission, you put the aircraft on the ground, you follow your fault tree, and you troubleshoot it, and it passes a traditional test using a traditional type of equipment, whether a DMM or even a bench test. It tests no fault found. So intermittent events are much different than that. So even while I'm talking, we are still testing. So Tony can tap a few more test points. And you'll see it illuminate there on test point 10 was just added. And it just glitched out at 50 events. It lights up in red there. We know that intermittent events on test point 50 is very intermittent. It's behaving sporadically. If we were to do the same type of test, which when we loop back through, we'll do that light tapping on test point 10, continuity, it would have to perfectly sync with that random event, right? So intermittent events are random in time, place, amplitude, and duration. A scanning tester will have to perfectly sync with those random events that do occur. And the odds of that happening are pretty slim, hence why no fault found exists. It is not about this technology being different or better than previous technologies. This is simply just purpose built to solve the intermittence failure mode. To see things that are random, I have to be monitoring in parallel, simultaneously and continuously across all circuits of the UUT. So now we're ready to look deeper into each one of these intermittent test points with multiple events. So what we will focus on first and foremost is probably that test point 10 that has 50 events. So we're going to actually stop our test once we've ran our environmental stimulus like we desire. And Tony's going to go ahead and push play to move to what we call fault isolation. And so on that fault isolation graphic on the left, you can see test point 10 up at the top left is illuminated there. Tony on the right hand side over to the far right can find test point 10 with 50 events, and he can click on the icon to bring up our meter. You can see there it just latched, and we're reading at about 18 ohms. There's about 17 ohms through the internal circuitry of the IFD, just so you know. But Tony can lightly tap, right? And you can see while we're dwelling on test point 10, so now we're not looking at everything. We have the onboard DMM focused in on test point 10, and it's showing open right now as he's pressing, and as he So what this allows us to do is basically go in and look at whatever test point we would like. And we will visually take those intermittent issues to root cause. So Tony, what kind of intermittent issues do you find when you go and visually take things to root cause?
Usually it's push pins, pulled pins, crimps, wire wraps, broken wires,
Cracked solder joints?
cracks, solder joints. About 80% of the problems are within those areas.
We've had a recent customer come to us where they had a failure due to a manufacturer of some harnesses putting incorrect gauge pins in their builds. And they pass all your functional sell-off tests, but they will not pass intermittent testing. The smaller gauge pins would behave intermittently in flight with temperature and vibration. So intermittence mode is very powerful. Fault isolation is where we go and we take things visually down to root cause. We're able to look at each test point that was behaving intermittently, one at a time. So now when we're done taking those all to root cause, we simply push play and we move on, and you'll see it goes to reports, and our test is now complete. On the reporting side, this is excellent. Now a technician can then leverage this report, which is saved out on the desktop in the Synapse Reports folder. So it'll split those reports into each test that we just ran, continuity, shorts, and intermittence. But we usually just like to look at the full report to get the full view of what's going on with the different failure modes. The continuity failure mode, it passed. You can see that there. Shorts failure mode, passed. And then in intermittence, you can see all the test points that Tony had lightly tapped showing up with the nomenclature and the number of intermittent events. So that's the report side. Go ahead and close that out, Tone. So once I've leveraged that report, repairs have been conducted. I'm going to verify now that this asset that I've just repaired has been repaired and it is intermittent free. Simply follow the same process of selecting our map, put the serial number in, push start, and it runs through the suite of tests. So this is now showing a continuity issue, which isn't a big deal. As Tony was tapping, we were playing with test point 10. There's still an issue with test point 10. Expected measurement from auto map is 19 ohms. Its reading is open. All we would simply do is verify that this switch, push it, kind of reset it, and then Tony will push the retest, and it passes. Pass shorts. Now in intermittence mode, we then walk through our environmental stimulus. So for harnesses, we use a simple vibration tool, which works great. With chassis on the IFDIS for LRUs, we integrate that tester with a chamber and a shaker to simulate that in-air environment even more. But with the sensitivity that we listen to with this technology, with IFD technology, we're listening down to 50 nanoseconds on every circuit. So the intermittence capability on this is very different than any scanning technology out there. Whether it's automatic wiring test set, AWITS, or a Dipmaco, or pinning something out manually, one pin at a time with a digital multimeter. Intermittence failure mode is very different than any technology. We are the only technology proven to meet MIL-PERF 32516, which is all about intermittence testing. So this, as we ran through our environmental stimulus profile here, we're just going to click stop as if we did it. There are no issues. That asset is now what we would say, we would call it's intermittent free, and it's good to be installed on any aircraft. And you are now going to experience significant increase of time on wing.